Hi, welcome back. So in this lesson, we are beginning chapter 2, and particularly we're going to work with section 2.1 today. But chapter 2 is all about finding limits, the slopes, and derivative. Okay, so those are the things we're going to be working on in chapter 2. So at the beginning of your section notes, it says that in this chapter, we'll be introduced to the idea of the slope of a curve at a point, or the derivative at a point. Those are both the same things, as you'll find out. This quantity is calculated using the concept of limit, which we're going to work on today. The limit concept is one of the foundations of calculus, and from this we will develop rules and formulas for finding derivatives. All right, so today in section 2.1, we're going to be looking at what are called left and right hand limits. Okay, so it says in this lesson we will determine what is happening to a function f of x as x approaches a number that may or may not be defined in its domain. And it says this will be done by looking at a graph or a table of values. All right, now this is real important here that you kind of keep this in mind when you're answering limit questions. It says in this lesson, we will determine what is happening to a function f of x. So when you're asked to find the limit, you are looking at what's happening to f of x. And remember, f of x is the same thing as y, right? Those are interchangeable. So we're going to give you an x value or an x value, or we're going to give you a value that x is approaching. Let's say that right. So your answer is going to be what's happening to y then. Okay, so just keep that in mind because you kind of have to wrap your head around that part to do the rest of this kind of easily and correctly. If you understand that, that will help you really get through this section pretty straightforward. All right, so our objective today in lesson 2.1 is basically just determining left and right hand limits. Okay, that's our job today. All right, so first off, we have a table. We're going to just fill this in. So we were given a function. So f of x is x squared minus 1 over x minus 1. And they're giving you the x values. And we're just going to write the y values. Okay? But let's take a look at what we're doing here. Because remember what limit is. We want to be approaching some value. So if you look at our numbers, we start at 2. Then we go to 1.5, 1.3, 1.1, 1.0, 1.0, 1.001. So these numbers are getting closer and closer to this number right here, right? 1. But if you look at 1, 1 is not in the domain of this function, right? If I put 1 in this function, I'm going to get 1 minus 1 in the denominator, and I'm not allowed to have 0 in the denominator. So even though 1 is not possible, I'm not going to get an answer there. That's not what I'm asking you for. We're trying to find the limit. So what does the y values, what do these numbers approach as we get closer to 1? So even though 1 doesn't have an answer, okay, this one does not have an answer. We're going to say DNE. Okay, that stands for does not exist. Okay, we cannot use 1, or you can say it's undefined, however you want to say that. But this value doesn't exist. Okay, we cannot put 1 in here. So I already know this isn't workable. But any other number is fine. I could put any other number in here and work it out. So it's set up at the top that we can either use the graph or table of values. Okay, so take out your calculators, pause this if you need to. I want to go through a couple of things with you on the calculator just to make sure we're okay. So the first thing, when you have a rational function, a fraction, where you have more than one term in the top and the bottom, always remember in your calculator you're going to put those in parentheses. So you're going to put parentheses around x squared minus 1, then you'll hit divided by, and then you're going to put parentheses around x minus 1. Okay, remember your x, the variable x is this button right here next to alpha. That's how you get x. All right, and then squaring in this problem, we would use x squared. That's how you get squared. And then the parentheses obviously are right here. Okay, Now, we could just put this in over and over again in our calculator. Put 2 in here, do 2 squared minus 1 over 2 minus 1. You can get the answers. You don't really need a calculator. This is not that hard. But I just want to make sure you remember how to use your calculator and how to graph. So we're going to go to y equals, and in y1 we're going to put this function. Remember, y is the same thing as f of x, right? All right, so we're going to put parentheses and then put the numerator, so x squared minus 1, close your parentheses, okay, and then hit divided by, and then parentheses x minus 1. Now you might say, why am I doing this? I could do this in my head. Yeah, that's true. But again, if you have a lot of numbers or a lot of decimal numbers, you would want to use your table in your calculator. All right, make sure you hit enter so that it registers. And now I want to talk about your table, okay? If you go to your table right now, which is second function graph, right? The blue, so second graph. You would probably see all the numbers. So it's showing you when x is 1, we got an error because remember, you can't use 1. When x is 2, we got y is 3. When x is 3, y is 4. Right? So there's 2. So when x is 2, the function value is 3, which again, you could have done in your head. That's fine. Okay. But notice there's not 1.5. All these decimals are not there. So I really don't want my table to give me just whole numbers. I want to be able to put these numbers in my calculator. So again, just want to go through this with you so that you have this knowledge and remember this as you go through this course. All right, so if you go to table set, okay, so that's second window. So if you go to second window, most of your calculators, you may not be starting at 1. It might be at a negative number or I don't know. But whatever it is, you can change that, but that's not important right now. But right now, your calculator should be set on auto. Auto means it's going to give you all of the numbers, just like ours showed. So what we want to do is we want the calculator to ask us what numbers. So go down to the independent variable and go over to ask and then hit enter so that it registers. And that's it. Okay, I'm going to arrow back up. Don't change the dependent variable, just the independent variable. Okay. All right. So now that you've done that, make sure you hit enter. Make sure the black box is around the word ask on the independent variable. Now we're going to go back to the table. So second graph to go back to the table. Okay. And then the numbers that are here, I'm going to hit delete. So if you hit delete, all those will go away. And now it's waiting for you to enter numbers. And you can put anything you want. So I'm going to put in the numbers that are on this table. So I'm going to put in 1.5 and hit enter. So there's the y value when x is 1.5, 2.5. Okay, I'll slide this over a little bit so I can get the rest of them in there. So I'm going to do 1.3. You don't need all those zeros. Okay, I'm going to do 1.1, 1.01, and 1.001. Okay. All right. So there are my y values. So I'm going to jot those down on the table. So 1.3, I got 2.3. 1.1, I got 2.1. Then I got 2.01. And then 2.001. Right? All right. So those are my values that I got on the calculator. Right? All right, so that's all it asks us to do is complete the table. But I want you to take a look at what's happening. So as the x values got closer and closer to 1, what did the y values get closer and closer to? Hopefully you see that these numbers are getting closer and closer to the whole number 2. Right? We're getting really close to just plain old 2. If I did 1.0001, I'd get 2.0001, which again is closer and closer to the number 2. Right? So those, or that, 2 is called the limit. That's what the function value is approaching when x approaches 1. Okay, that's in words. That's what that sounds like, and that's what we're getting ready to look at. Okay? All right, so let's move on. I'm going to keep this right there so you can see it. All All right. So part A on the next page says, in this case, we say that as x approaches 1 from the what? Are these numbers bigger or smaller than 1? Okay. If you look at these numbers, they're all bigger than 1. Numbers bigger than 1, remember on the number line, if this is 1, these numbers are bigger on the right side and these numbers are smaller on the left side. So if we're using numbers that are bigger than 1 but approaching 1, then we say that we're approaching from the right. Okay, bigger numbers. So we say that as x approaches 1 from the right, f of x approaches what? F of x would approach 2. Okay, that value right there, what we're getting closer and closer to. Not 2.001. Okay, what number are we getting close to? All right, so here's the notation. This is what you're going to see. The limit as x approaches a from the right of f of x. Okay, so it says the arrow signifies the word approaches. So the limit as x approaches a, and then it says the plus sign indicates x values approaching a from the right or from above. Now it says above, but above is to the right on a number line, so you got to think about it. These are bigger numbers, right? 2, 3, 4. Doesn't matter. As long as they're bigger, we're approaching from the right. Numbers smaller than 0 would be approaching from the left. Okay? So in this case, 2 is called a right-hand limit. All right. We don't know that if we put in numbers smaller than 1, okay, and get close to 1 that way, what we're going to arrive at. It may or may not be 2. Might be something totally different. So right now, all we know is that 2 is the right-hand limit for this function. Okay? All right. So now let's look at number 2. Complete this table. All right, let's take a look at these numbers. 1.5, 1.9, 1.99, 1.999, 1.9999. So we are getting closer and closer to 2. Again, 2 cannot be plugged into this function. Now our function is x plus 1 over x minus 2. If you plug 2 into here, in the denominator, you will get 2 minus 2 is 0. You're not allowed to have 0 in the bottom. So again, there is no function value at 2. 2 is not in the domain. We cannot use 2. Okay, remember when we found the domain in chapter 1, right? X can be every number, but it cannot be 2, right? You set the denominator, you find what the denominator cannot equal. All right, so these numbers, now you can see why I want to use my table, because I want, you know, I can put in whole numbers and work it out, but I don't want decimals. I don't want to have to worry about that. So please use your calculators. So this is good. Let's practice again. So we're going to go to y equals, clear out what we did last time. So hit your clear button, which is under the arrow pad there. And now we're going to, again, parentheses, x plus 1. Close your parentheses, divided by parentheses, x minus 2. Okay, and then hit enter to make sure that it's entered into there. Okay, so now we're going to go back to the table, second table, and it's going to keep all the numbers we used earlier. So we want to delete those. So just hit the delete key, and then we'll just start over. I know we're using 1.5 again, but that was it, right? All right, so we're going to do 1.5, 1.9, 1.99, 1.999, and 1.999. All right. Now, we got -5 when we used 1.5. We got -29, then -299. I'm going to move this for a minute so I can write. Then we got -2,999. And finally, -29,999. Okay? All right. So if you look at these numbers, they're not approaching anything. They're not getting closer and closer to anything. They're getting smaller and smaller, right? I mean, the number's growing, but they're negative. So this is a really large negative number and so forth, right? So these numbers are getting smaller and smaller, and they're not going towards anything in particular. So if they just keep getting bigger, or if they keep getting smaller, then they go to either positive or negative infinity. Okay, so in this case, they're getting smaller. So this function, as x approaches this number, is approaching negative infinity because we didn't get close to any number. So we're going to fill this in. So in this case, we say that as x approaches 2 from the left. Why did I say left here? Look at these numbers. They are smaller than 2. Yes, they are getting bigger, but these numbers are smaller than 2. So these are on the left side of 2 on the number line. So we were approaching 2 from the left. And we would say f of x then approaches negative infinity. Okay, we didn't get a number. We did not get something it was approaching. So it says in this notation, we have the limit as x approaches a from the left of f of x. The minus sign indicates the x values are approaching a from the left side or from below. And what did we get for the limit? We got negative infinity, so that is called the left-hand limit. Okay, so you have to be very careful on these problems we're getting ready to do. Pay attention to the sign. Is it from the left or from the right? That's that little plus and minus sign. Okay, all right. So now we've got a couple other definitions, and just to make sure you understand, and then we're going to work some problems. All right, so number 3 says, if p is a polynomial function and a is a real number, then the left limit as x goes to a is equal to the right limit. Okay, so remember what a polynomial is. Okay, no fractions. It's just like, 5x squared minus 3x plus 2. Polynomials. The limit from the left and the limit from the right of the polynomial will be the same number. Okay, will be equal to each other. All right, number 4. If f of x increases without bound as x approaches a from the left or from the right, we say that f of x approaches positive infinity. All right, so we just said that. If the numbers get really, really big, then we're going to positive infinity. And number 5 is what we just did up here. Okay, the numbers decreased without bound. So those we say f of x approaches negative infinity. Okay, so those are pretty straightforward. And then number 6 says, this is kind of tying it all together, for a function f and a real number a, if the limit of x as x approaches a from the left of f of x equals L, and the limit as x approaches a from the right of f of x is L, so notice these are the same, L, where L is a real number, then the limit as x approaches a of f of x equals L. And notice there's no plus or minus sign here. So what does that mean? Okay, so that says if the left and the right-hand limits of x equal a are the same value, then the general limit exists and is equal to that same value. So you got to pay very close attention today if you're looking for numbers that go to from the left of x, from the right of x, or if you're asked just what's the limit as x approaches a. If you're asked just this, then you have to do both sides and make sure they're the same. Okay? You can't do it one way and give an answer. So pay attention. This is from the left, this is from the right. This means check both sides and make sure they're the same. Unless, of course, you have a polynomial. If you have a polynomial, then you know it's equal. You don't have to do both sides. It will be. Okay, that's what number 3 says. Okay? All right, so let's work some problems and see how we do with that. So we're going to start off with the graphs, just because a lot of times that helps visual. You can visualize this a little bit better before we work on the algebra part of it. All right, so here's a piecewise graph, right? Pieces of functions. So we have function values and we could find the function value, but today we're looking at limits. Limits are not function values, okay? Sometimes they might be the same, but they're not, they don't have to be. All right, so we got to pay close attention to the direction that we're going. All right, so in number 1, part A, find the limit as x approaches -5 from the left of f of x. So this is f of x. All of this whole graph is f of x, okay, the whole thing. All right, so where's -5? -5 is right here. Now remember, they're giving you the x value. When you find the limit, we want to know what the y value is getting close to. Y value. So from the left would be numbers smaller than -5, which are over here. So we're going to look at this side of the graph. Okay? So right here, this would be the function value as when x is -7. So as I approach -5 from the left, so here I am at -6, getting closer, the y value is this, 5. The y value up here was 7. And as I get closer and closer to -5, what is the y value approaching? Okay, the y value is approaching 3. So this is 3. Okay. All right, now we're going to approach 5. Sorry, we're going to approach -5 from the right side, from above. So again, here's -5. So numbers bigger than -5 are over here to the right. Okay, so I'm just going to start here at -3. Okay, and I want to approach -5, which is here. So when x is -3, the y value is 3. As I approach -5 from the right, so here I am at -4, I'm at +4 for y. And as x approaches -5 from the right-hand side, the y value is approaching +5. Okay? So again, you are looking at the y values. Okay? All right, look at part C. This time we're going to approach 1 from the left. 1 from the left. So here's 1 right here. So from the left, that negative sign means I'm going to be coming close to 1 from this side, right? From over here. So that's this graph right here. All right, so here I am to the left of 1, and I'm approaching it from the left. So what does the y value approach on this side? The y value would approach right here, -1. It doesn't matter that it doesn't exist. It's what we're getting close to as we get close to 1. Okay? It doesn't have to be a closed circle, because I didn't ask you what the value was at 1. I just said what's the limit, and the limit is what we're getting close to. Okay? All right, and lastly, the limit is x approaches 1 from the right. So that would be on this side. So we want to come this way, which is this piece of the graph right here. So as we move along the graph, getting close to 1, the y value is getting close to 2. Okay, so that's the y value. All right, so that's how you kind of look at the graphs. You kind of follow the graph on whichever side you need to be on until you get to that point. All right, so we're going to try it again with number 2. All right, so this time on part A, number 2, we're doing the limit as x approaches -4 from the left. So -4 is right here. I always like to kind of just put it here so I can see it. So I'm going from the left side, so that's over here. So as I get closer and closer to -4, still not at -4 here, right? -4 is the line. So this means it's going to continue to go down. So that means I'm going towards -infinity, okay? It's not going to touch it, right? That's an asymptote, so we're going down to -infinity. But this part B says, what happens on the right-hand side of -4? Well, that's this side, right? Right to the right of -4. So we're going to come towards -4 this way, from the right. And as we come towards -4 from the right, the y value is approaching 1. Okay, +1. All right, one more time we're going to do the same thing at 3. 3 from the left, 3 from the right. So again, find your 3. It's over here. Okay, so from the left of 3 would be this side. Right. So we're going to approach 3 over here. Okay. So as we approach 3, what is y getting close to? Y is getting close to 4. Doesn't matter. That's open. I'm still getting closer and closer to this y value of 4. And as I approach 3 from the right, that's this side of 3. So if I approach it this way, again, notice it's not crossing the line of 3. The arrow is going to keep going up, and so that is positive infinity up there. Okay? All right. So looking at the graph, that's how I would find the left and the right limits. Okay? All right. Let's move on. All right, number 3. Now we're doing, number 3 is a polynomial. So remember what the polynomial said. If you have a polynomial, the limit from the left and the right are the same, and you can just plug in the number. So I don't have to do 1.9999 and look at all that. If you have a polynomial, you can plug the value of x right into here and get your limit. Okay, so the limit as x approaches 2 from the right, I would just do 2 squared plus 4 times 2 minus 2. Okay, so that's 4 plus 8 minus 2. So that's 12 minus 2, so I get 10. So that's the limit. Okay, so for polynomials, the nice thing about it is you can just plug in the number. A good rule of thumb for you guys to remember for all equations that you're given, you can always plug in the number, and if you get an answer, that will be the limit. Okay? The only time you have to use a table or the graph is when you plug in the number and it doesn't give you an answer, which we did on those first 2 tables. Okay, so always remember the first rule of thumb is to plug in the limit value and see if you get an answer for y. Always do that first. You can always check that. Okay, so we'll do that as we move through today. All right, so look at number 4. Find the limit as x approaches 1 from the left of x minus 2 over x minus 1. Okay, well, I'm going to try putting 1 in here, but if I put 1 in here, I can't, right? 1 minus 1 is 0, can't have 0 in the bottom. So I can't just plug it in. This is not a polynomial. So I need to either use the table, right? Or I could look at the graph, however you wanted to do it. So I'm going to go and graph this. Okay, so I'm going to go to y equals, and I got x minus 2, so I'm just going to use what I had, just change it a little bit, over x minus 1, and then I'm going to hit enter. So it just changed what I did earlier, so I just changed those numbers. Now I want to go from x from the left. Think about that. Here's 1, it's positive 1, right? And we're going to come from the left. So from the left, here's 0, and then we're going to do 0.9, right? Here's 0.99, 0.999, right? I'm going to get closer and closer to 1 from the left. So I can't go to 1, but so I'm going to use a lot of 0.9s. All right, so we're going to go to the table, second graph, hit the delete key to get rid of what was in there. And so I'm going to do 0, enter. 0.9, 0.99, 0.999, so I can get as close as I want to 1. Okay. So again, these numbers are growing rather largely, and they're not going towards anything. They're just getting bigger and bigger and bigger. So that means that the limit as x approaches 1 from the left of this function would be positive infinity. Okay? Positive infinity. So I'm going to write this down. It's always good to have these numbers if you go back and study later. Okay, so we did 0.9, 0.99. So just jotting these down from the table, but it's good for you guys to see these if you look at your notes later on. right? So those are getting bigger and bigger. All right, so that answer was infinity. All right, number 5, another rational function, but I can still check. Maybe they didn't give me a number that gives me 0 in the bottom, but they did. Usually they do. So as x approaches 5 from the left, I can't use 5. 5 minus 5 is 0, so I again have to do the table. All right, so you're doing 5 from the left. So again, just be careful with the numbers you pick. So from the left means smaller than 5, right? So this is 4 over here. So we can do 4, we can do 4.5, we can do 4.9, 4.99. We're going to get closer and closer and closer to 5. It doesn't really matter the numbers you pick, just at the end you want numbers really close to that. Okay, so we're going to pick those numbers. We may have to get bigger, but I think that's good. And we could do 4.999. I just ran a room on the number line there. Okay. All right. So again, I'm going to go back to y equals. And because I just have the same kind of answer, I'm just going to substitute in 9 for 2 and 5 for the 1. Both were minus. Just make sure. And then hit enter. So it registers and clears out the old one. Go back to your table, hit delete, get rid of those. And then we're going to put in these numbers. So 4, 4.5, 4.9, 4.99, 4.99. Okay, again, notice that these numbers are growing largely. They're not getting close to anything in particular. They're getting bigger and bigger and bigger. So that's another one that's going to go to positive infinity. No matter how close I get to 5 without going to 5, these numbers are going to keep growing. Okay, so we got 5, 9, 41, 401, 4,000. So this would go to positive infinity. Okay, and a lot of times with rational function that happens, but remember the very first one we did not, right? Number 1, back on the first page, we didn't get infinity. Okay, so just, always check. Okay, always check. Now, I'm going to just take this problem, y equals, and I want to graph it. So if I hit just graph, don't go to the table, just hit graph. And we look at what happens at 5, right? Here's 5. 1, 2, 3, 4, 5. So 5 from the left, that was what we just did, goes to positive infinity. 5 from the right, that would have been negative infinity. Okay, so you can look at the graph. Sometimes it's hard on the graph if it's, a number because it's hard to see on your graph, but you can always tell the infinities pretty easily. So you can look at the graph. That's why it's real important that you put these guys in parentheses when you graph. If you don't use parentheses, you're going to get the wrong answer. So make sure if you have more than one number in the numerator and denominator, put parentheses around them. Okay, if you're going to use your calculator. Otherwise, your calculator is going to give you the wrong answer because you put it in wrong. It's not because it did it wrong. All right. Number 6. The limit as x approaches 0 from the left. Can't use 0 because that's going to give me 0 in the bottom. So I have to use the table or the graph. So again, which way is left of 0? That would be over here. So the first number smaller than 0 is negative 1. So what are numbers that are going to get closer and closer to 0 between negative 1 and 1? So we know we can do negative 0.5, and then we could do negative 0.1, and then negative 0.01, right? So we want to get closer and closer to 0. So we're going to have 0.0001 as we get closer and closer. Okay. So I'm just going to pick some of those. So let's start with negative 1, negative 0.5, negative 0.1, negative 0.01, negative 0.001. That should be good enough. So we're going to put this in the calculator. So I'm going to go back to y equals. I'm just going to clear that out this time, and I'm going to put parentheses x plus 46, close my parentheses, divided by x. Now x is just one term, so I don't need parentheses around it. You can put parentheses around it. It's not going to hurt. Okay? All right, and then we're going to go to our table, and we're going to clear those out, so hit delete. Don't hit clear, you hit delete on that, okay? All right, so we're going to do -1, -0.5, -0.1, -0.01, -0.001. All right, so again, you can see quite easily these numbers are growing, but this time they're growing in the negative direction. So the limit would be negative infinity. Okay, negative infinity. So again, you don't have to write these down, but it might be good. So when you go back and look later, you have these numbers. Don't want to have to do all that again. All right, so those are getting closer and closer to negative infinity. All right. Number 7, I'm going to do this a little bit differently. You could just as easily put that in the table and do it just like we did, okay? But I'll show you sometimes, those of you that remember how to factor, we can also simplify. So I know that I can factor this top by grouping. Now I know if I put 9 in here, I can't use 9. 9 minus 9 is 0, so I have to do something else. So you have the calculator, you have graphing, you can use a table. But if you can simplify and cancel, reduce this down, and get rid of the x minus 9, that'll work too. Leave you with a polynomial. Okay, so I want to remind you how to factor by grouping. I know some of you did the work on factoring, but just in case. So you always group the first two things together, and then I'm going to put a plus sign there, and we're going to group the second two things together. Always want to start with a plus sign between the second and the third term. So if the third term's negative, I always kind of write it this way. And then all you have to do is factor out a greatest common factor from each of these. So on this side, what do these terms have in common? They have a 3x squared in common. And if you factor out a 3x squared from both of these, it'll leave you an x here and 9 there. Right? Divide both of them. So if you divide 3x cubed by 3x squared, you're left with x. If you divide 27x squared by 3x squared, you get 9. All right, on this side, I want to factor, anytime the third term is negative, I want to factor out a negative number. So what do these both have in common? They have a 3 in common, but I always want what the first thing in the parentheses is to be positive. So anytime that third number is negative, just factor out a negative number. So if you divide both of these by -3, -3 divided by -3 is 1, so it just leaves you x. 27 divided by -3 leaves you that. And remember, if the factors here are the same, then you group these two together. So I can group 3x squared and -3. So the numbers out front get grouped together. And then as long as these are the same, that's the other factor. So these make up one factor, and then this is your other factor. So now I have the limit as x approaches 9 from the right of 3x squared minus 3 times x minus 9 over x minus 9. Okay, so now in algebra, if you have like factors, remember you can cancel those. So if those cancel, now I have the limit as x approaches 9 from the right of 3x squared minus 3. Now I have a polynomial, and remember for polynomials you can just plug the 9 in. So now I can plug in the 9, so that gives me 3 times 9 squared minus 3. 9 squared is 81 minus 3. 3 times 81, that's 243 minus 3, so we end up with 240. Now, if you use the table, obviously that's probably faster, but I just want to show you, because sometimes you get problems that are not too hard to factor, and so that's another way to do it. So again, rule of thumb, you can plug in the number into a polynomial. So when I saw that I could factor this, that's the way I chose to do it. But graphing it or using the table will give you the same answers. Okay, you'll get closer and closer to 240. All right, we've got a few more to do now, piecewise functions, okay? I'm going to go ahead and continue. I know I usually stop for 30 minutes, but let's go ahead and knock these out because these do not take long. All right, so we've got piecewise functions. Piecewise functions, if they're polynomials, remember you can just plug in the number. You just got to put it in the right place. All right, so we're going to use negative 8x minus 7 when x is less than negative 1, and we're going to use negative 5x cubed plus 3 if x is greater than or equal to negative 1. So part A asks you to find the limit as x approaches negative 1 from the left. From the left means smaller than negative 1, so that would be these numbers less than negative 1. So we can plug negative 1 right into here. So that'll be negative 8 times negative 1 minus 7. Okay, negative 8 times negative 1 is positive 8 minus 7. So the limit as x approaches negative 1 from the left is 1. Why did I use the top? Because I needed to come from the left of negative 1, which means numbers smaller than negative 1, and that's numbers less than negative 1. That's smaller than. Okay, so now for part B, what's the limit as x approaches negative 1 from the right-hand side? Well, those are numbers bigger than 1, which would be numbers greater than 1, right? Negative 1. So now I'm going to use this and plug in negative 1 here. So negative 5 times negative 1 cubed plus 3. So leave the negative 5 there. We're going to cube negative 1. Negative 1 times negative 1 times negative 1 is negative 1 plus 3. So negative 5 times negative 1 is 5 plus 3. We get 8. Okay? And lastly, in part C, find the limit as x approaches negative 1 of g of x. Well, remember, if there's no plus or minus sign, what has to be true? These two have to be the same. The limit from the left and the limit from the right have to be equal for this to exist. So this one does not exist. Okay? Remember, this is true. I don't have to solve this. If they ask me for this, I have to look at the left and the right. Okay? All right, so let's try that a couple more times on the last page with numbers 9 and 10. Same exact thing. We're going to look at the left limit, the right limit, and then see if there's a limit that exists. Okay? All right, so again, we're going to use the top polynomial if x is less than 5. We're going to use the bottom one if x is greater than 5. So first one, part A, find the limit as x approaches 5 from the left. Left is smaller, so that's less than. So we're going to plug 5 here. So we're going to do 5 squared minus 1. 25 minus 1 is 24. So that's the limit from the left as x approaches 5. Okay? Now, what's the limit as x approaches 5 from the right? Numbers to the right of 5 are bigger than 5, so we're going to use this. Well, what happens there? Okay, if I do 1 over 5 minus 5, I can't do that. I get 0 in the bottom. So now I got to go to the table and look at that. So numbers bigger than 5. So I'm going to just over here. Okay, here's your number line. Here's 6. So we want to do 6, 5.5, 5.1, right? 5.1, 5.01. That's what we want to look at. We're going to get closer and closer to 5 because I can't put 5 in here. It's not a polynomial. But there is a limit. Okay. Remember, the limit is what you're getting close to. So go to your calculator. And we're going to put in y equals 1 divided by parentheses x minus 5. Close your parentheses. Hit enter. Go to your table. Delete out those numbers. And let's put in these numbers that we said here. 6, 5.5, 5.1, 5.01, 5.001. Okay, so what's happening to these numbers? They are getting bigger and bigger, right? So the limit as x approaches 5 from the right is infinity. Okay, based on that. I couldn't plug it in here because I got 0 in the bottom. Sometimes you can, sometimes you can't. All right, so does the limit as x approaches 5 of f of x exist? These have to be the same. No, they don't. No, they aren't. Sorry about that. It's getting late on my side over here, so no. So these are not the same. So the limit as x approaches 5 of f of x does not exist. All right, last one. All right, so again, this one will be good because we got two polynomials, so we don't have to do any tables. We can just plug in the numbers as long as I can get an answer. So I'm going to use the top one when x is less than 2, so that's from the left, right? And I'm going to use the bottom one when x is greater than 2, so those are numbers that approach from the right. Typically when you have a piecewise function, this is the way they give it to you, but pay attention. Because if they put the greater than up here, you got to put it in the right place. So just always look. That's why I've been saying that. I know you can read it, but it's always good to double check. All right, so 2 from the left, the limit of as x approaches 2 from the left of function g, so g of x would be, we're going to plug in 2 right here. So that's 2 squared plus 1. 4 plus 1 is 5. Okay? All right, so that's the limit from the left side limit. Now we're going to do 2 from the right. So we're going to plug in 2 here. So that is 7 minus 2, which is 5. All right. So notice the limit from the left and the limit from the right are equal. If they are equal, then the limit as x approaches 2 exists. Okay, and it is the same. So the limit of g of x when x approaches 2 is now 5 because I checked the left and the right side. Okay. All right. So you guys need to have a real good understanding on these limits. So please start your homework as soon as you can and make sure you feel comfortable with this because we need this to move on. So don't procrastinate on the homework. Okay. All right. Thanks for working with me. I'll see you back here next time.